Motion can be fairly complex, and we're excited to look into all that complexity. But to start, let's focus on a type of motion we call uniform motion, which is basically constant speed. Okay, so if you consider a car, here's my simple car, and it's moving, and from here to here, it moves at the same speed throughout that entire time, so we can give it this velocity v throughout the whole time. We'd say it's undergoing uniform motion, or again constant speed. And there's a lot we can do to describe this, and a lot of real things in life can be reduced to pieces where it's constant speed for at least short time intervals, and we're going to look at that. So first of all, let's try and think about how we can describe this graphically and then mathematically. So for example, if I were to choose a coordinate system here, we'll call that direction x, and we could say, well, at some time, let's say time equals 0, the car is right here, and at some later time it's over here. If I were just to qualitatively plot that, I'm starting my time 0 at x equals 0, and I'm moving in the positive direction at a constant speed. Okay, now constant speed means a constant rate of change of position with respect to time. So on a graph, that would be a line, a straight line with a constant slope. Okay, so the slope is equal to the speed. So the slope of a position versus time graph is equal to the speed. So a straight line, okay, means a constant speed. If we were to plot the velocity as a function of time, again, it's moving in our positive velocity. It's moving in our constant positive direction. That means we have some constant value, and the value here is unchanging. That's uniform speed, constant speed, uniform motion. And the value here, whatever this is, we'll call this, let's say v0, which means this would be v0 here. It's some value that's not changing, and that is equal to the slope here. Okay? And since the slope here is the same as the slope here is the same as the slope here, the value here is the same as the value here is the value here. And so graphically we can relate these with the slope of a position versus time graph, or the value of a velocity versus time graph. And we can go back and forth. If I know the velocity versus time graph, I can draw the position versus time graph, or vice versa.